I'd like to make a video explaining the class note solutions. We're going to go ahead and start with Chapter 1. Now, Chapter 1 is really an introduction to kind of refresh your algebra. So you'll notice that you have blank notes and you have the class note solutions. I'm really going to focus on section 1.4, so I'm going to quickly go through 1.1, 1.2, and 1.3. But please take your time, go through the notes, check out the solutions. But it's really an algebra refresher, and the course really begins with Chapter 3. But Chapter 1 and 2 are very important to make sure your algebra skills are ready for the calculus that we'll learn in this class. So I'm just going to go quickly through the first couple sections. But in section 1.1, you'll talk about what a function is. Every x has to have a unique y and what that means. So this is a function, this is a function, this is not a function because this x is 7, where the same x has a different y. So every x has to have a unique y. Remember that. Vertical line test is an example. So you can remember how a function is written and what it looks like. An example of functions, function notation, all the things you learned in algebra. There's a little calculator step by step so you can practice calculator usage. This is using the TI-83. Some examples, plugging into a function, a word problem with function, piecewise graphs. Notice the graph behaves differently at different places. Review that. Graphing a function, filling in a table. Your calculator can help you with that as well. A word problem. Being able to graph a function is very important and understanding it. The vertical line test. Remember, a vertical line test, if it's a function, when you draw a vertical line, only crosses one point. Examples there. Again, piecewise functions. Know your basic graphs. What a x squared would be a parabola, quadratic equation. This would be a hyperbola, cubic equation. What a square root looks like, a cube root. 1 over x squared. Kind of what they look like. This would be linear, since it's to the first power. What an absolute value looks like. And then in 1.3, again, things you definitely need to know. What a linear function. Remember, y equals mx plus b. In that form, m is the slope, b is the y-intercept. What an x-intercept is, what a y-intercept is. Review all of this, things you should know. Slope is the change in y over the change in x. You remember the slope formula, given 2 points, how to calculate slope. Here is a linear equation and y equals. You would first start with a y-intercept, -3, and the slope is -4 over 1, so I'd go down 4. -4 to the right 1 for +1. Again, things you should know, converting to slope-intercept form, a word problem using that. Given 2 points, find the equation of a line, step by step, with another example using point-slope form, which is possible. And then some examples for you to try. Again, very important things you should know walking in the door. We don't want to have issues later, so I have this refresher for you. What a graph of y equals or x equals looks like. Parallel and perpendicular. Parallel lines have the same slope. Perpendiculars have negative reciprocal slopes. Some examples to practice. Definitely spend some time in Chapter 1 and make sure we're all on the same page. Some examples to practice. And then I'm really going to spend a little time on section 1.4. 1.4 is using everything that we just talked about. So I'm going to review the answers. If you need the full lecture, watch that video as well. So, for example, cost could be looked at as a linear model, where if we did like y equals mx plus b, cost would be our output, and then m would be our marginal cost, mx together would be our variable cost, and b would be our fixed cost. An example would be, to rent a moving van, the cost is $29.99 for the rental and 25 cents per mile. So if I wrote this as a function, your cost in terms of x being how many miles, is 0.25 cents x plus $29.99. So to break that down, the marginal cost is 25 cents, which is our slope. It's 25 cents per mile. Remember, slope is output cost over input mile in this case. Make sure you know your input and your output. Very important. The variable cost, again, is the slope and the x, is 25 cents x. And it's variable because it changes. So it's 25 cents per mile, depending on how many miles. And our fixed cost, the cost that doesn't change, is $29.99. Then we have a couple examples, being able to plug in 100. The cost for 100 miles would be $54.99. The cost for 50 miles would be $42.49. Revenue, on the other hand, is your marginal revenue times X, depending on what that is. So your input would be X, could be how many pizzas or whatever it is, and then your output is revenue. Profit is revenue minus cost. Profit is revenue minus cost. And then break even is when revenue equals cost. So we have an example here. The manager of the frozen air refrigerator factory notices that on Monday it cost the company a total of $25,000 to build 30 refrigerators, but on Tuesday it cost $30,000 to build 40 refrigerators. So in this case, if you want the linear cost function, we're provided with 2 points. Here are 2 points. Again, this goes back to those previous sections. Very important that you label your input and your output. Your input in this case is number of refrigerators. We need to know that first. That's our independent variable. And your output is the cost. So that would be your dependent variable. So in this case, we have 2 points. Input, 30 refrigerators. Output, $25,000 is the cost. Input, 40 refrigerators. The cost is $30,000. And again, this is where the review comes in. Given 2 points, you first find the slope. Once you find the slope and you can plug in a point, you can find your y-intercept. And then you have your cost of 500x plus 10,000. Again, the fixed cost is $10,000. And then 500x. 500 would be your slope, which would be your marginal cost. Remember, that would be like the cost per refrigerator. Output over input. So that would be 500 over 1. Your output cost, 500 over input number of refrigerators. Every one refrigerator costs $500. Then I tell you that Frozen Air sells its refrigerators for $1,500. What's the revenue? So if we're selling each refrigerator for $1,500, that would be your marginal revenue. And then we don't know how many refrigerators, so that would be X. 1,500X. 1,500X would be your revenue. And then to find your profit, it's revenue minus cost. Notice we put cost in parentheses because we have to subtract each piece. We don't get to keep that $10,000. It's not part of profit. We have to subtract $10,000 because it's part of the cost. So when we simplify, we have 1,500x minus 500x, which is 1,000x, which if we really understand this, each refrigerator we're making $1,500, but it cost $500. So our profit would be $1,000 per refrigerator, but we have to subtract out those fixed costs. So make sure everything makes sense. Now, if we're going to sketch a graph of the revenue and cost, we need to first figure out how many refrigerators, and then we label the money is your output. So input, number of refrigerators, output is money for both, and we'll graph our revenue and our cost. Notice our revenue is the one that has the y-intercept of 0, and it's 1,500x. And then our cost starts at 10,000, and it's 500x. Now there's 2 ways to do it. One, you can find the break-even by hand, if we're looking for break-even, which would be where the 2 intersect. So to do it by hand, we take our revenue, set it equal to cost, solve for x, which we'd be very comfortable with, and we get 10. Remember, input is number of refrigerators, so 10 refrigerators. And if I plug 10 into the revenue or the cost, this is where they break even, you get 15,000. So at 10 refrigerators, you break even where the revenue and cost are the same. Now, this can also be done in the graphing calculator. Okay, so I brought up a calculator, and this is an example of your graphing calculator. This is the TI-83. So what I'll be doing is I'm going to graph, remember, these 2 functions, the revenue and the cost. So I go to y equals, I'll turn it on first. This is kind of a larger one. There we go. Turn it on. Go to y equals. The first one is 1,500x, enter. And then the other function was 500x plus 10,000. Now the calculator is very helpful to figure all this out, but you have to understand the problem. The calculator does not just do it all for you. You have to understand the problem. So for example, I need to know how many refrigerators this is going to take. And so if I go to the work I did by hand, we know the answer is 10 for the x-axis, and we know that it's 15,000 for the y-axis. Without that, you'd have to plug in numbers, try, see what works, but you'd have to make sure, don't just go to graph, because I don't know what it's going to look like. So we go to window. Remember, we know that the x answer is 10, so let's say 0 to maybe 20 refrigerators, counting by fives. And then we know the money is 15,000, so let's say 0 to, let's say, 30,000. 1, 2, 3, counting by 5,000. Now again, hopefully you've had some experience with the graphing calculator. If not, use the step-by-step notes to help you in the notes that I provided. But again, y1 is the revenue, y2 is the cost. We hit graph. There's the revenue. There's the cost. You will not see this unless you understand the problem and understand the window. We want to find where they intersect. So we're going to hit second trace, number 5 for intersect, then enter 3 times. 1, 2, 3. And it tells you that 10 refrigerators for $15,000. Okay? Then and again, it's all graphed here, so I always recommend doing it by hand first. Then, what does that mean, break even? Well, if you sell less than 10 refrigerators, you're going to lose money. Going back to the picture, here your cost is above your revenue, you lost money. If you sell more than 10 refrigerators, your revenue is above your cost, you've made profit. So that's the first part of chapter 1.